Hello everyone, welcome to week 2's lecture video. In this video, I'm going to be covering contents for chapter 1. You see my cat is making an appearance. Her name is Chia. She's 4 months old. Right, before we get to the lecture materials, just brief reminder about homework 1, depending on when you're watching it, is due this coming Tuesday, August 18th by 11:15 at 9 p.m. So make sure you submit that under D2L assignments. Few more things that are coming up this week. Our homework 2 and lab assignment 1, both are due next Tuesday at 11:59 p.m. There are going to be videos on how to do lab assignment, whether you're using a school computer or your personal laptop. So make sure you watch that video before you start with your assignment. Attendance quiz is available on D2L under quizzes, and these are extra credits that serve as like a review for the content that particular week, and you have multiple attempts to get the high score, so make sure you utilize those opportunities to get extra credits so that your final grades will be higher. Chapter 1 is Introduction to Statistics and Research, and a lot of people start this course feeling you're familiar with neither. A lot of people feel intimidated by the word statistics and research, but in fact, we see statistics and research everywhere. I'm sure you've heard user statistics or any statistics online that describe, oh, this many people out of this many people do this. And you can see in this example too, there are 6 out of 10 people prefer online video platforms to live TV now. And there are 8 out of 10 people who watch YouTube. And there are 74% that does this. So all this are ways that people's pattern of behaviors or trends get communicated in numbers. And research is a way for us to find evidence and so that we can get closer to the truth. So whether you see a dermatologist tested sign on your shampoo or skincare products, you want to make sure that research has been conducted and we know that it's safe, right? Especially if you're taking certain medications, right? So whatever the research topic is on, research helps us in a scientific way to get closer to the truth, to the laws of nature. And psychology is a type of science, is a social science. And in psychology, we use research to collect data and make meanings about those data to find truth about human behaviors, human or animal behaviors. And those data could be on intelligence, memory, or personality traits like extroversion. And we try to make sense of those data to find meaningful truth about our behaviors. And statistics is a tool that psychologists use to analyze the results of their research, the things that they collected on their data. So statistics is essential for psychologists to conduct and comprehend the research. So here you see the table of raw data. So from these set of students, 2 sets of data have been collected on optimism and number of correct. And maybe this researcher wanted to find out whether people are optimistic or not contributes to their performance on a test. So these are ways that psychologists get closer to finding any pattern of behavior. Statistics serve 4 large functions to help us make sense of the data when we have them. The first 2 is to organize and summarize the data. First, when we have raw data, they are very hard to see patterns unless they are organized in a meaningful way. So we organize this data either in the table that you saw in this slide or the graph like this. When you organize the data into table or graph, it helps us to recognize a pattern easier. So you see here that higher the IQ, higher the GPA, and that's easier to see when we have organize the data in a graphical form. Or you can also summarize the data to understand general characteristics. So here, instead of knowing that, okay, so Jordan had scored 60, Pippa scored 72, and so on in their optimism score, maybe it helps me to know, okay, so on average, how optimistic were the students? So that's one way to summarize the data. And once you have organized and summarized the data, you can also use statistics to communicate the results of the study. So what is the implication of this study? What did you find out? So statistics gives us standardized, uniform way to communicate scientific finding across different fields, across different countries, and so on. And statistics also help us interpret the results. Okay, so what we found here in statistical way is this. So what does that imply about actual human behaviors? So basically, statistics is a way to think about numerical information in a new, different way with real human data. And the best way to learn statistics is to do statistics, to run statistical analysis, to find ways to organize, summarize, and interpret the results using statistics. And in this course, we're going to use the software program called SPSS that looks like this. Any school computer has this, whether it's computer labs or library computers. And there's also a way for you to access SPSS on your personal laptop if you go through Radford Virtual Lab. I'm going to go through this process more in details in a separate video for lab, so make sure you watch this video for your lab assignment. So in essence, in the lecture, we're going to cover some actual contents and learn about statistical concepts. And in labs, you're going to apply this concept into actual data so that when you are taking 302 or 491 in the future, you have some strong foundation in how to do the statistics yourself. So like I said, psychologists conduct behavior research to get closer to finding these laws of nature, the absolute truth that applies to human behaviors or animal behaviors. And to find this truth, we usually find a specific behavior in a specific situation, and we want to see whether that generalized to broader behaviors and broader population. So if I notice that students act like this in my particular course, can I make the assumption that that's how all students in all courses act? We don't know. We find that out through research. And we also test hypothesis in that process. We make an educated guess. Okay, so I think that students will score better on the exams if they sleep more the night before. Once I make that educated guess, I collect data, and with data using statistics, I test my hypothesis to find whether it's true. That's the process of statistics. And in statistics, you always have the population that you're interested in. So the population is the entire group of scores, entire group of people or participants or data that you're interested in. Maybe you're interested in finding these laws of nature in all humans or all women, all students at Radford, all residents of Virginia, okay? But for obvious reason, it's impossible to collect data on all this population, right? And that's when you take the sample of that population and actually measure data from that particular sample. And individuals that are measured in a sample, we call them participants. So we have participants that represent the sample, and that sample should represent the population. And whatever we find in the sample, the scores and behavior we find in the sample, we use that to infer, meaning estimate, generalize to the scores and behaviors in the population. Okay, and in order for us to infer properly, we have to make sure that we have a representative sample that accurately describes the population. So let's say target population is all psych majors at Radford, and there are approximately like 500 of you. So it's very costly time-wise and money-wise to collect data from all 500 people in the population. So we take just a subset of that population and we take the sample, and we only have 20 participants that are included in a sample that is representing the original population. But when we do that, we have to make sure that this sample, that these 20 people are representative of this 500 people in the population. So whatever characteristics that you find in the population, especially demographic population, we have to make sure that sample is closely resembling that. So if target population, there are 50-50 ratio of female and male, maybe you should have 50-50 ratio of male and female in your sample as well. It doesn't make sense for you to have all women sample or all men sample when your original population had 50 and 50. So again, you have population of interest, whether it's all Virginia residents, all human beings. It's hard to test all of them, so you use a sampling procedure to have a sample that's almost accurately representing the population, and whatever we find in the sample, we use that to make an inference estimation about the population. Okay, so this is what we found in the sample, so it must be true for all the population. I find that from my 20 students, psych major students, that they are all conscientious. Then that must be generalized to the population, and it must be that all psych majors at Radford are conscientious. That's the process of making an inference. And in research, you're interested in several variables, and a variable is anything, any factor that you're interested and it can produce 2 or more different scores. So example variables could mean age, race, gender, personality traits, and so on. So let's say, what are some factors that contribute to success in this course? So I want to get an A. What are some factors that contribute to me getting an A in this course? It could be that I come on to D2L frequently. It could mean that I check emails frequently so I don't miss any assignments or announcements. No, it could mean that I assign 3 hours per day to study for stats. It could also mean that I'm just a very conscientious person. And all different factors could be a variable that influences another variable, your grade. Okay, so you can measure scores in each of this variable to see how it relates to another variable. That's process of research. And there are 2 major types of variables. It can either be quantitative or qualitative. When the variable is quantitative, you see the word quant here, it means quantity. So it reflects an amount, a quantity, measurable quantity. So it can be represented in number, whether it's height, GPA, age, income, and so on. On the other hand, qualitative variable has qual here, means it reflects a quality. So instead of quantity or amount, it has a quality or it's a category. So it does not amount to a number. Like hair color, there's no number or amount to hair color, right? There's no extent of how brown your hair is or how black your hair is. Same thing as race or relationship status. It's quality or category instead of an amount. So these are 2 major types of variables. So going back to this previous example, if I ask how many hours of stat studying you do every day, that's quantitative because I'm getting the number. There are specific number how many hours people study. Same thing with maybe checking emails. If I ask, how many times do you check emails per day? Again, that's a number. I check 3 times or 1 time, 5 times, that's a number, okay? So that's, again, quantitative variable. So in research, we all always try to understand relationships. So in the previous example, I try to understand the relationship between different factors that could contribute to the final grade in this course. So in different variables might have different relationship. When the scores on one variable tend to change along with the scores on the other variable in a consistent fashion, then we determine that there must be a relationship. So maybe low study times are associated with low test grades, or longer you sleep tend to lead to fewer doctor's visits, or more conscientious you are, you tend to make more money. Those are all different relationships that you can study by looking at the pattern of how different variable scores change with one another. And there are 2 different types of statistics we're going to learn in this class. So like I said, statistics is a tool that psychological researchers use to make sense of their data in their research, right? Descriptive statistics is used to describe sample data when we try to organize and summarize sample data. Remember, those were the functions of the statistics, right? Another type of statistics is inferential statistics. We're trying to make an inference, right? Remember, we use sample data to make an inference about the population. This process was called infer. So inferential statistics is used to decide whether can we make a generalization, can we make an accurate inference about the population based on what we found from the sample. And there are 2 ways, 2 different languages that we use to communicate the scores of the variables. Statistic is referred to the number that describes sample scores. So whenever you see English letters used, that means those letters are referring to the scores that are representative of the samples. But when you see Greek letters used instead of English alphabets, that's when the scores are representing the population. Okay, so these are the helpful acronyms that you can use. Sample statistics, so statistics is English letters that refer to sample scores, or population parameters. Parameters are Greek letters that represents the population scores. And when you're collecting data, you have to have a design based on how you're going to collect data. How is the study laid out? That's the design. And depending on what type of design you use for your study, you use completely different types of descriptive or inferential procedures. So when you're collecting data, you have to first determine what type of design are you going to use for your research. And there are 2 major types of designs: experiments and correlational studies. In experiments, researcher manipulates the independent variable and then measure how dependent variable changes based on the independent variable. So independent variable is actively changed or manipulated by the researcher, whereas dependent variable is something that's getting measured that is being influenced by independent variable. Dependent variable is dependent on the independent variable. And within the independent variable, there might be multiple categories of how it's manipulated, and that each of the category is considered, is called condition. And in each independent variable may have multiple conditions. So if I want to measure how many hours students sleep per day, and their productivity the next day. And I manipulated students to either sleep 3 hours, 6 hours, or 9 hours. That the number of hours students sleep is an independent variable because I, as a researcher, is manipulating how many hours students are sleeping, either 3 hours or 6 hours or 9 hours. And dependent variable is productivity. And that's something that's getting measured. And I'm seeing how this gets influenced by this independent variable. And in this example, we see 3 conditions because people were either required to sleep 3 or 6 or 9 hours. So whenever you see something that's getting actively manipulated, that's an independent variable, and that means it's an experimental design. Okay. So in this example, let's say I wanted to determine the effect of having pets on health of children. So I divided children into 2 groups, and I gave no pet to a group of children, and I gave one or more pets to another group of children. And since I'm manipulating how many pets each group of children are having, that's our independent variable, having pets. And there are 2 conditions because you can either have no pet or one or more pets. And finally, dependent variable is something that's getting influenced by the independent variable. And here, that's health of children. However, in a correlational study, no variable is being manipulated by the researcher. The researcher only simply measures participant scores on all the variables they're interested in instead of manipulating anything. So example, anxiety versus palm sweat, or introversion versus GPA. So none of these variables are manipulated, but are simply asked, how introverted are you? What is your GPA? Or you just measure people's amount of palm sweat they have. When you're simply measuring without manipulating anything, it's a correlational study. Again, so if you see nothing is manipulated in an example, that means it's a correlational study because there's no independent nor dependent variable. When you collect data, you have scores, right? And those scores will have different mathematical characteristics. And depending on the types of mathematical characteristics they have, again, it determines the types of statistical procedures you can perform. And there are 4 types of measurement scale and 2 characteristics of the measurement scale that we're going to go over. First, nominal, ordinal, interval, and ratio. The simplest type of scale of measurement is nominal. The nominal here, NAMI, represents the name. So it's categories or classifications of individuals. It's not an amount. There's no quantity. So things like gender or nationality, hair color, those are categories. Those are just labels of the categories, and that's a nominal variable. Ordinal variable has ordi in the word, and it has an order. It has a rank order. But there is no 0. And the 2 scores are not separated by the same amount. So class standing is one example, freshman, sophomore, junior, and senior. And there's no 0 in those categories, right? And the distance from freshman to sophomore is not equal to sophomore to junior or junior to senior. Why? Because each class standing is classified usually by the number of credits you take. And let's say you're a freshman and you have taken 12 credits so far. You're a sophomore and you've taken 30 credits. You're a junior, you've taken 50 credits, and you're a senior, you've taken, let's say, 72 credits. And you see the distance from one category to another, it's not equal distance. And same thing if you came in different, your rank in your race. So you came in first place or second place, third place or fourth place. The distance between first and second might be by a few seconds, whereas the distance from the second to fourth might be an hour. Okay, so in ordinal variable, the scores are not separated by the same amount. In interval and ratio variable, those variables indicate an actual quantity, and they have an equal distance from scores from one another. But in interval, it does not have a true zero, whereas ratio, it does have true zero. So how does that differ? So interval, in the example of interval variable is temperature. So you can see that 70 to 71 to 72, there's equal distance, right? Each distance of 1 represents the temperature of 1 degree. So it's equal distance. And the number 70 represents the amount of the temperature. But there's no true zero in the temperature. The zero in temperature, if something is 0 degrees, it does not mean absence of temperature or absence of heat or absence of cold, right? It just simply is another indicator. It's another amount of the temperature. On the other hand, in ratio variable, there is true zero. So things like height, length, or weight has true zero. So something can be 0 inch or 0 foot or 0 pound, right? It actually means the absence of height or absence of length or absence of weight. So in that case, these true zero means it is a ratio variable. And finally, there are two types of characteristics in a score. It can be either continuous or discrete variable. Continuous variable is when decimals make sense. Okay, so 2.5 makes sense. 2.5 can happen in this particular variable. Whereas in discrete variable, decimals make sense. It has to be a whole number. 2.5 cannot happen. So let's go over an example to see how this can be applied. So number of tickets sold to an event. The first thing you want to determine and to know which measurement scale is, it is to first see if 0 makes sense. Can you sell 0 number of tickets? It makes sense. You can sell 0 number of tickets. When 0 makes sense, it automatically is ratio, because ratio is the only measurement scale that has true 0. And now you have to determine whether it's continuous or discrete. And you determine that by asking yourself, do decimals make sense? Can you sell 2.5 tickets? Can you sell 3.1 ticket? No, right? You can either sell 1 ticket, 2 tickets, or 3 tickets. Then it becomes discrete. So this particular variable is ratio and discrete. How about your flavor preferences in soft drinks? So if I say vanilla is first, second is cherry, third is whatever, you're putting an order, so it's ordinal. But it's discrete because can you have vanilla and half or 0.1 cherry, right? So it's discrete. Weight is easy because 0 exists in weight, right? Something can be 0 pound or 0 ounce, 0 gram. That 0 means absence of weight, so it's ratio. And it's continuous because, again, decimals make sense in weight. So you can weigh 200.1, 300.5. Those decimals make sense in weight. So it's a continuous variable. Similarly, IQ. In IQ, there's no true 0, right? In IQ, 0 does not mean absence of intelligence, right? So it's interval. Because in IQ, 100 to 101, 202 still has an equal distance. It's just that there's no true 0. So it's interval variable, and you could have decimals technically in IQ, so it's continuous. All right, so that's all I have for chapter 1, and I'll see you at the chapter 2 lecture video. Thank you for listening.